We want to simplify this algebraic fraction. So the first thing we're going to do is factorise the numerator and the denominator. So let's focus on the numerator first because it's a little bit easier because it doesn't have the 2 at the front. So we need 2 sets of brackets. We know it's just an x and an x at the front because you've got an x squared here. And we need to have 2 numbers that are going to multiply to make -4 and add up to make +3. So that's going to have to be a +4 and a -1. 4 times -1 is -4, and 4 plus -1 is 3. So we factorise the numerator. We are now going to do the same thing with the denominator. So we're going to factorise this. This case, it's going to be slightly harder because we've got a 2x there. So we know it has to be a 2x and an x. Now, it's going to be a +3 on the end. So we know that these 2 numbers are going to have to multiply to make 3. So it could be a 1 and a 3, or it could be a -1 and a -3. It can't really be anything else. It has to be a 1 and a 3, or a -1 and a -3. There are no other numbers that are going to multiply to make 3. Now, considering that they've got to add together to make a -5 when I do all the multiplying out, considering I've got a -5 in the middle, I know it's not going to be the positive ones. It's going to have to be the negative ones because of this in the middle here. So then it's just a case of working out, should that be the -1 or should that be the -1? So let's just check this. If I said that was the -1 and that was the -3, would that work? So let's check. Would that work? Would this give me the -5? So 2x times -3 would make -6x. -1 times x is -x. So I'd have -6x minus x, which would make -7x, not -5. So that's wrong. So it must be the other way around. That must be the -3. That must be the -1. Let's check that though to make sure that's correct. So 2x times -1 would make -2x. -3 times x would make -3x. And then when we add those together, we've got -2x minus 3x, which makes -5x. So that is correct. So we factorise that correctly. And in the context of this question, actually, we know that this is going to be correct because we've done these sort of questions before and we know that we should get to the point where something cancels. So if that's an x minus 1 on the top, we're expecting to get an x minus 1 on the bottom as well. So there's our answer. For part B, we want to express these 2 fractions being added together as a single fraction in its simplest form. So we want to add these 2 fractions together, so we want a common denominator. So at the moment I've already got an x plus 2 on the denominator here, so I want to times top and bottom by x minus 2. So if I do that, I'll get 4 lots of x minus 2 over x plus 2 times x minus 2. So that is my new equivalent fraction to the 4 over x minus 2. We'll now do the similar thing with the 3 over x minus 2. So I'm going to times top and bottom here by the x plus 2. So I'll get 3 lots of x plus 2 times x plus 2 times x minus 2. So again, this is my equivalent fraction to the 3 over x minus 2. And the point is, we've now got a common denominator. So I can now actually combine these 2 fractions to be a single fraction with x plus 2 over x minus 2 as the denominator. And on the numerator, I'll be left with 4 lots of x minus 2 plus 3 lots of x plus 2. Now I just want to simplify it. So let's expand out the brackets on the numerator. So 4 lots of x is 4x, 4 lots of minus 2 is minus 8, plus 3 lots of x is 3x, 3 lots of 2 is 6. I'm not going to expand the denominator just yet, because what we might see in a minute maybe is some cancellation like we had up there. Possibly, maybe not, but you don't need to expand it anyway. Right, let's simplify the numerator. So I've got 4x plus 3x is 7x. I've got minus 8 plus 6 is minus 2. The denominator can stay as it is. And no, we're not going to get any further simplification here. This 7x here is not going to cancel with anything on the bottom. So we'll just leave our answer like that. That is your final answer in its simplest form. If you wanted to expand the denominator, you could do, but you don't have to. It's perfectly fine as it is.